Welcome to qnawire.
Okay, let's take a look at the question. So it said draw a picture, not to scale. Let's schematically represent the process and label all non-distances and angles. So from the given conditions, we know that the wavelength is 520 nanometer, and the grating is with 4,000 lines per centimeters, and the distance between screen and the grating is 1.6 meter. So, sorry. That's a graph for the first question. So there's a grating right here on the left side with a bunch of lines, and there's an interfere wavelength. Interfere waves, since there are so many slits in the gratings, and those slits are the lines, and the screen on the right side, and the distance between the grating and the screen is 1.6 meter. So let's do some calculations here, so that we can make the solution for the later questions will be easier for us to solve. So you said it's 4,000 lines per centimeters for the grating, and we can set that equal to 4,000 lines over 10 to the negative 2 meters, since 1 centimeters is 10 to the negative 2 meters. Then we will get 4 times 10 to the power of 5 lines per meter. And in order to get the separation between two slits, since it's a relationship of each lines is a relationship of the separation distance between each lines from the gratings. So we simply just put 1 over 4 times 10 to the 5 lines per meter, which will give us 2.5 times 10 to the negative 6 meter. So the separation of a double slit is equal to 2.5 times 10 to the negative 6 meter. And for question B, it was asking us to determine angular deflection of the second bright band. So remember, the formula for the angular deflection is sin theta m equal to m lambda divided by d. And m here is equal to 2 since it's second order bright band, and lambda is 520 nanometer, and the d is 2.5 times 10 to the negative 6 meter, which is the separation of double slit. So since we know m is equal to 2, so simply just calculate sin theta 2, which is equal to 2 times 520 times 10 to the negative 9 meter, because 1 nanometers is equal to 10 to the negative 9 meters, and we are converting nanometer to meters to make sure the units is synchronized. And so it's 2 times 520 times 10 to the negative 9 meters divided by 2.5 times 10 to the negative 6 meter, which will give us 0.416. In order to figure out the angular deflection, which is the angle, theta 2 here, we need to plug in the 0.416 back into the inverse sine function here, and then we get the angle is about 24.6 degree, which is around about 25 degree. So for the last question, it was asking us to determine the separation of the second order bright spot from the central maximum. Okay. So there's a formula for such question, which is ym equal to L times tangent theta m. And we know that m is equal to 2, since it's talking about the second order bright spot. So just simply y2. So y2 is equal to L tangent theta 2. And we also know that L, which is just the distance between the screen and the grating, which is 1.6 meter. So we plug in the data, it will look something like this. So it's 1.6 meters times tangent 25 degree And once we plug in all these data to calculators, we'll get something like this, which is let me see 0.746 meters, which is 74.6 centimeters. And that should be the answer for the last one. Thank you.